Hi to all. Today's topic is frequency of LC oscillations. Okay. Now in the last topic we discussed that when a capacitor which is fully charged, if it is connected to the inductor, the energy stored in capacitor will be exchanged between the capacitor and inductor. Okay, initially the capacitor is fully charged, that's why it has energy. Then if it is connected to the inductor, then it supplies the energy to the inductor. Then after that, after some time, inductor starts to supply the energy to the capacitor. That means the energy exchange between the capacitor and inductor, and the charge and current in the circuit oscillate with the time. The charge will be increases when the capacitor discharges, the charge in the circuit increases. When the capacitor charges, the charge in the circuit decreases. Like that, the charge varies with the time, and the charge will do the oscillations. That oscillating charge in LC circuit can generate the electromagnetic wave. In LC circuit, we can generate the electromagnetic wave with certain frequency. That frequency is equal to the frequency of charge which is oscillating in the LC circuit. Okay. Then we have to find out that frequency. For the purpose, let us consider Q0 be the maximum charge on the capacitor at time t equal 0 second, and Q is the charge on capacitor at any instant of time, and omega is the angular frequency of LC oscillations. Angular frequency of LC oscillations. Let us see here. These two are in parallel combination, capacitor and inductor. Then we can say that the potential across the capacitance equal to potential across the inductor. That right, we can write from figure, right? What we can write? Potential across capacitance. Potential across capacitance is equal to potential across capacitor is equal to potential across inductor. Potential across inductor. What is the potential across capacitance? VC, right? Potential across inductor, VL we can take. But potential across capacitance, if Q is a charge at any instant of time, we have C equal to Q by V. From that, V equal to Q by C, we write. Okay, Q by C. Potential across inductor, it is nothing but EMF induced across the inductor. That EMF induced formula is L dI by dt. We know these formulas. Okay, right. And from this, we write one thing here. What is the current in the circuit at any instant? Okay, the current in circuit at any instant. Current in circuit at any instant, we write like this. At any instant, we write as Q is equal to, current. Current is the rate of flow of charge. Okay, with how much rate the charge decreases on the capacitor, with that much rate the current charge increases in the circuit. That means the current is equal to, we write as the rate of flow of charge, but here the charge is decreasing on the capacitor, that's why minus dq by dt we write. Minus this we substitute in this equation, then what you will get, right? And this we can take as the equation 1, and from equation 1 we write like this. The Q by C is equal, we write as this we write as from equation 1, right? From equation 1, what we write, right? Q by C is equal, we write as L into d by dt of I is the minus dq by dt, we write. This we can write as, in the mathematics, you remember that this minus n we write outside. L is the constant inductance, and here d by dt, dq by dt means differentiation. Okay, double time we are doing the differentiation 2 times. Then this we write as d square, we write d square q by dt square we have to write. Okay, and then this we take to left side. Then we will take a d square q by dt square into L plus q by c is equal to 0. Then from this we write, we can divide with L here. When you divide with L, then d square q by dt square plus this we write as q by LC, or we write 1 by LC into q we write. Okay, here we are dividing with L. Divide with L. Divide with L on both sides. Okay, when we divide this equation we will get. And the next this we can take as the equation 2, right? This is the important equation. Let us continue now. Here the equation of SHM, charge is oscillating here. This is the oscillating equation actually. Equation of SHM, we know that. Equation of SHM means simple harmonic motion, right? Then according to that we know, for example, any loaded spring is oscillating like this. Okay, it has some displacement x. When it is pulled down and released, then it will do the oscillations. It will goes up and down. Then it further general equation is A equal to minus omega square x. Okay, A we write is acceleration rate of change of velocity we write. But the velocity we write is the rate of change of displacement dx by dt we write. Then here displacement one time differentiation means velocity and other time differentiation means acceleration, that is equal to minus omega square x. If you simplify this, d square x by dt square plus this minus omega square goes to left side, omega square x equal to 0. This is the equation of SHM, right? Equation of SHM is d square x by dt square plus omega square x is equal to 0, right? Now compare equation 2 and 3. Compare equation 2 and equation 3. What you will get? Right, you see here, instead of x here q is there, instead of x q is there, instead of omega square lc is there. We write omega square as 1 by lc and omega we write as 1 by root lc. Omega we write as 1 by root lc from this. From this if you want to write omega, okay, then we will get as root lc. I will continue here, a little bit space we have it here. Then here next step is omega is equal, we write as 1 by root lc. This is the frequency of LC oscillations, frequency with which charge oscillates in LC circuits. With how much frequency the charge oscillates in LC circuit, with that frequency the EM wave will be generates. This is EM wave. Okay, right. Let us see here, this is the angular frequency, but if you want the linear frequency, we know that, but omega is equal to, we know, 2 pi nu, we write here. Then the 2 pi nu is equal, we write as 1 by root LC. From this, nu is equal, we will get as 1 by 2 pi under root LC. What is this nu and what is that omega? Omega is the angular frequency, nu is the general frequency, frequency of LC oscillations. Frequency of LC oscillations, right? Okay. This is about the frequency of LC oscillations. This is the formula for the angular frequency and this is the formula for the linear frequency. Where we will use this LC oscillations, and right in our radio we have the LC oscillation circuit. It is oscillates with certain frequency, and here from certain radio station they will send the electromagnetic wave with certain frequency. If that frequency will matches, then it can vibrate and we will get a clear sound. We will get the clear sound. This is the used in the tuning circuit. We will set certain frequency in our radio, right? Then for that, this by changing the inductance and capacitance, we can set this as for certain frequency. That means this is used in the used in tuning the circuit, right? Tuning circuit we will use. This is the we will use to tuning certain frequency, and to generate the EM wave we will use this one. To generate EM wave we will use this one. These are the uses, and now this is about the frequency of LC oscillations. Okay, if you have any doubt you can ask me. Thank you for watching my lectures.